Welcome back. This is the last set of talks of the conference. You made it. One quick announcement immediately after the conference for those here. We're going to be doing 2 birds of a feather sessions based on what folks voted on in the channel. One on submitting good PRs, and I've forgotten the second one already, but it's on the Forward CloudSec website. So meet us immediately afterwards for some good discussions. We had one yesterday. Before we get started, I'd like to thank my sponsors, especially Netflix. Netflix is the world-leading streaming entertainment service available in over 190 countries. We push unprecedented cloud technological boundaries to efficiently deliver streaming service at massive scale over the internet. Come help us secure this massive footprint in the public cloud with a combination of innovative and unique cultural challenges. Please welcome Max.
Hi, everyone, and welcome to Building Blocks for Zero Trust Internal App Defense. My name is Max B. I am a security engineer with a focus on cloud infrastructure, and I work at Figma. Figma, if you haven't used it, is the design platform for teams who build products together. We're a web-based design tool used by UX designers, engineers, and people who are just thinking of the next big thing. And so our tool is critical in their flows to ideate and then design tomorrow's products. So as an engineer, I like writing the code once and using it in a bunch of places efficiently. I like creating infrastructure engineering experiences that surprise and delight my coworkers. Wow, that was so easy, or I didn't know it was so fast to get something secure running. I like over-engineering my personal website so I can deliver my tiny resume with the best in security and performance technologies. What I don't like is when my small but scrappy security team has to spend a lot of our cycles doing things like SRE work, or rebuilding a server, or spending a lot of toil to create the security benefits that we require in our systems. Specifically, today I'm going to be focusing on internal web apps. These tools that are often developed in-house and run critical parts of your infrastructure. But keeping them truly safe is a challenge. And if you doubt that, just ask a red teamer. I used to do some pen testing operations, and it was frequently the quickly put together, not very well-protected internal web application that eventually gave me the keys to the kingdom. An example of this, and one that I'll kind of be coming back to throughout this talk, is this app that I'll call deploys.figma.biz. So as an agile software development company, we're constantly deploying our application to various environments with various versions. And so we needed an efficient app that would let us do this and do it safely and do it effectively. So this is a really powerful and high-value web application. This is the thing that pushes the code that runs on our production infrastructure. And so protecting it is paramount. As we go through today, I'll talk about these building blocks. I'll talk about how we built up defenses here that were remarkably low toil. But first, I use that buzzword zero trust in my title. So for our purposes, I see zero trust as a way to have an internet-facing deployment. We don't have a corporate VPN, with strong authentication of user and device so that we can get the guarantees that we need that only authorized users are using this app, while maintaining minimal exposure of the sensitive internal services that power all of this. What we're trying to create here today is a drop-in set of protections for our web applications that will apply to deploys, but also anything else that anyone at Figma wants to build. We want to use the best available in modern authentication, and critically, we want this to be easy to maintain and operate because we have other things we need to build. We don't just want to maintain systems. These are some of the building blocks I'll be talking about today, step by step, going from the bottom up of the core technologies that power this to some pretty cool extras we were able to build using modern cloud technologies. Let's start off with AWS Incognito. These are AWS components, and at Figma we primarily use AWS. But a lot of the ideas here, I think, abstract well to other cloud providers, and there are probably equivalent acronyms that you could find in GCP or Azure that would do similar things. So to begin with, the ALB, or Application Load Balancer, which is a Amazon-hosted reverse proxy that allows you to send your traffic around. ALBs are great because they send your HTTP traffic where it needs to go and handle a lot of the challenges of running a proxy on the internet. But critically for our use case, they also authenticate your traffic. ALBs natively integrate with OpenID Connect, or OIDC, and allow them to plug into a large set of authentication backends to identify a user before they allow that traffic to pass to the underlying application. So roughly, our setup that we're going to create looks like this. A user will send their traffic to an ALB. ALB will talk to Cognito, which is an AWS service that handles user management and authentication. And critically, Cognito can also plug into arbitrary SAML backends. So if you have a company identity provider like Okta or OneLogin, Cognito can authenticate users with that backend. The ALB can use Cognito to establish someone's identity and authenticate them, and then it will forward that traffic on to your application. Looking at each part of this and sort of the security benefits we're getting, between the user and the ALB, Amazon is handling things like the TLS stack, patching the instance, all those things that are sort of unpleasant about running Nginx on the internet. What version of OpenSSL are you running? What FIPS compliance standard are you at? That sort of thing. Amazon is sort of managing for you. Yes, there can have been flaws in this, and there have been vulnerabilities in ALB in the past. But again, as the member of a very small security team, I really would like the backup of Amazon's rather large security team helping me run my front-end load balancer. In between the ALB and Cognito connection, so Cognito uses OpenID Connect or can present an OIDC front end, and then it can connect to sort of arbitrary backends. In our case, we're connecting to SAML because we're Okta users. But you can also do your own user management within Cognito if you want to, or set up more complicated user pools depending on your specific needs. Finally, the ALB will only send you traffic after the security checks have been performed. So you know that at the point where your traffic is coming in, a user has been verified. So with this, we put our deploys app behind an ALB, and now it's got strong authentication. As soon as you try to visit it, you're going to get redirected to our Okta login page here. And then all of that authentication stuff will be sort of handled by our standard authentication flows, logging, et cetera. We've now covered the first two building blocks here. Application load balancers provide us this ability to gate traffic before it enters the internal network, and we can do strong authentication using existing auth stack with Cognito's SAML integrations. But let's start getting to that modern authentication I mentioned. Your identity provider. So modern identity providers have started adding a bunch of really powerful features that allow us to be much more sure about who is logging in than we used to be. In the old days, when we were talking about authenticating someone to an internal app, you'd probably be using something like, well, we want to make sure users are on the VPN, it's only accessible internally, et cetera. And so fundamentally, your point of control is how do you get on the network? Can somebody plug in, or can they get on this VPN client? And we've seen a lot of flaws in these systems over the years. So what we realized is that there's a lot of really powerful new authentication features that are available to modern clients, and most IDPs now are rolling out support for them. So where we once had simple VPN and where your identity is really just this IP address, now we've got YubiKeys. And YubiKeys support WebAuthn, which is highly phishing-resistant multi-factor authentication, and it's in the browser. And it works across phones and laptops, and you can even use things like Touch ID if you want to kind of go the biometric route. So we can use WebAuthn to get really high levels of phishing resistance on our applications. We have things like device trust. So various certificate-based schemes provided by a few of the management systems out there that can authenticate devices as well as users. So your IDP can have restrictions like, well, we want to make sure that a user logs in with a correct password and has a WebAuthn multi-factor and is on a device that has a certificate that we issued within the last 30 days or something like that. So you can start stacking up these pretty powerful authentication requirements, giving you much stronger guarantees than your VPN had, and these are all just sort of available at the click of a button. JSON Web Tokens come in here, of course, or JOTs as they're sometimes called. When you connect an identity provider like Okta through Cognito into ALBs, Okta can actually provide signed assertions of user information in HTTP headers. So if you configure this, you can set up a jot to come through into your underlying app that has a signed assertion about what octa groups the user is in. And so this allows us to create things like specific fine-grained permissions. Critically, all of this is configurable per application. So depending on the internal web app that you're protecting, you can select the set of authentication controls based on what you need. Maybe you want some of your apps to be accessible by users' mobile devices and don't want to have a strict device trust, for instance. The application can confirm these defenses are in place because they can do things like verify those jots and make sure that security has been maintained through the whole chain. And these things are set up with a few clicks inside your identity provider. There's no custom code required to create these controls. So now, on our deploys app, we can add more specific permissions. So we can say like, okay, well, you have to be authenticated to be able to see the app at all, but you also have to be in certain octa groups if you want to actually trigger a deploy as opposed to just seeing what's out there. And we can do this because our identity provider is forwarding along signed information about users' octa groups into the web application where it can then make further identity decisions. And you have to use WebAuthn to log in, so phishing a user trying to get into the deploys app is remarkably hard. So that was our identity assertions via JSON Web Tokens and stronger IDP authentication. These are other things that we set up with a few clicks. We've got to parse the JWT. That's a little bit of extra code you need to write. But these are highly reusable standards compliance protocols. And so far, we've built up automatic authentication through an IDP, a centralized gateway like that, and added a bunch of modern authentication defenses. But let's see if we can get fancier. So our third building block here, I titled Serverless Superpowers. And I'll give an example of one of the things that we're able to use some serverless functions for, but there's a lot of options here. So we're talking about a deploys app, right? Meaning so it's in large part used by the infrastructure team. And in fact, they wrote most of this. And so the question quickly came up, do we have to use a web UI? Like, you know, we've been working in the shell forever. Yes, it's a nice, pretty web application, but can we get a CLI that can call these APIs as well? And at first glance, this is kind of challenging. If you want to create something like a run deploy script that invokes a web API that's hosted behind this ALB, it's kind of challenging because the stack that we have built uses a lot of very browser-dependent functionality. We've got things like redirects to identity provider, WebAuthn support, device trust stuff. Like, these things would be kind of hard to implement purely within a Python request context or something like that. And so we thought about how can we make this a smooth experience that, again, users are delighted to use, but still allows them to have a CLI experience. So we set up this interesting flow. A user CLI library that we wrote, a developer of a CLI can just invoke this library. It will open a local web server port running on localhost, and then send the user's browser to a well-known URL at the ALB. The ALB has a high priority rule that when it sees that well-known URL, well, first of all, it authenticates the person like it always does. But when it sees the request to that well-known URL, it will route to this generic Lambda function. And this is a Lambda function that the security team was able to write once and will work for any ALB that is fronting an internal app like this. That Lambda function will present a page that asks the user to confirm whether or not they want to authenticate this CLI app. So far they've invoked the CLI, a browser page opened, and they'll see something asking them, are you sure you want to authenticate your terminal to this application? Once the user confirms, that Lambda function will send the user's cookies necessary to authenticate through the ALB back down into the locally running web server so that it can then send future requests through into the API that's behind that ALB. Obviously, building a flow like this, we had to have some strong security controls. There's a state token used to prevent flow hijacking, so you can't get in the middle of this. We have a highly restrictive CSP on the confirmation page to try and avoid any possibility of cross-site scripting attacks, and the CLI will abort if it can't bind to the port. One thing I'd like to call out is that because this is Figma, even if you're just setting up a CLI authentication page, you got to have nice fonts, so our CSP does include those. And this Lambda code is service agnostic. It'll work for deploys, but the same Lambda can be invoked for basically any service. The cookie-based sessions are widely supported, so it doesn't really matter what else you built your CLI tool in. As long as it can send cookies along with its requests, it'll work. And this can be enabled in 3 lines of code from the developer's perspective. They have to set a Terraform variable to turn on this ALB feature and create the Lambda, which is a module we wrote, and they have to call the library and import the library, but that's it. So basically, Lambda's awesome, and we love it, but who doesn't? We've now built up our full set of building blocks here. We started with the ALBs, we added a bunch of modern authentication features, and then we were able to add some powerful extensions with serverless features. So in conclusion here, because we're about to run out of time, there's a few core components in modern cloud infrastructures that can provide powerful security guarantees. And these things can go beyond what we're used to working with when it was just authenticating internal apps by a VPN or internal IP address. Deploys.figma.biz, that app we talked about earlier. It was once just it started as a basic internal web app someone wrote, but now it can authenticate users with our central SSO, making user management easy. It can check for WebAuthn and device trust when somebody logs into it, giving us much better guarantees about what sort of device and what sort of users are accessing it than we had before. It can grant individual permissions via octagroups. And it has a fully CLI-compatible API because we have this Lambda in place. And critically, the amount of code that the security team had to write in order to maintain all of this was really low. We created this Lambda, and we do continue to maintain the code for that. But being a serverless function, it tends to have a lot less maintenance cost overall, and so far it's required very little maintenance. Using and sharing these managed components can greatly reduce the maintenance costs for security teams, especially if they're busy, and it can externalize a lot of the risk and challenge of running these systems onto larger entities like your identity provider or your cloud provider that are better prepared to handle them. In short, the rising tide lifts all ships. When we can reuse these components and share these core functionality between companies and organizations and use these powerful primitives that cloud providers are giving us, we can generally make things on average more secure and make it so these internal web apps stop being such a soft center and great target for pen testers. That's my presentation for today. So if you would like to stay in touch, here's my email and Twitter, and then there's a bunch of bit.lys there for more information about this. Thank you very much.
Thanks, Max. A couple questions. First, do users have to auth to each app the first time they use it, or can you share sessions across multiple instantiations of this?
Good question. So that depends on how you set up your Cognito implementation. So basically, an ALB can plug into a particular Cognito user pool, and then you have to authenticate to the pool once per however long you want that session to be. So it really depends on sort of your threat model here. We generally use about day-long sessions, but it is possible to have multiple apps share the same pool if you think that those authentications go well together.
Thanks. Was there any discussion of build versus buy here, and how did you land on build versus buy?
I think really our discussion was, well, we're almost buying it, right? There was a little bit of building here, but mostly it was just plugging the right parts of Terraform and our identity provider together. And moreover, we felt that some of the really more advanced authentication features we're covering here oftentimes are not super well supported yet. And so we wanted access to sort of the newest stuff, which I think is not always present if you're buying, if that makes sense.
So for security teams that would be interested in replicating this work, like roughly how much time did it take to build this? Like what would we want to budget for that?
That's a good question. This was done over a period of a few months as we found more things to add in. My original setup with the ALB, Incognito, and stronger authentication controls, I think took me about 2 weeks. If you go to the bit.ly/Figma blocks, I have a more detailed blog post about the specifics of this. And if you email me, I will also happily send you Terraform configs that just do it. So if you're looking for a little bit of an accelerator, happy to send that along to you.
Sold. Last question, I guess, on operations is who supports this, right? There is and what is the support burden of something like this? Anytime you give something that end users touch, there's inevitably a support burden.
Yeah. So by externalizing a lot of the stuff to the IDP side of things, there's a fair amount that is supported by our IT team doing their normal operations. Because instead of inventing our own system of authorization or access control rules, we're just using Okta groups, which is what they were already familiar with. So that was a big win for support for us, is that instead of now the security team owns its own permission system that it has to do ticketing for, we can just sort of share that with them. There are some questions that I get, and my team does get, about like, how does an ALB work? I want to do this special configuration with a rule. But because we also use ALBs throughout our infrastructure, knowledge of how ALBs work is pretty widely distributed. We're not using anything particularly fancy here. So like anyone who builds something, there is some ongoing cost of people having questions and looking for ways to extend it. But by trying to stay away from truly bespoke solutions, there's a lot of people around who can help.
Thanks. Any other questions in the room? All right, one more from me.
Yeah.
In the previous talk, we talked about authenticating against S3 backends. How close is this to being able to do that?
Yeah, so it's pretty close, but you'll still need something like how Envoy was used in that last presentation. As far as I know, there's no immediate way to get an ALB to make requests against a private S3 bucket. I thought about doing it with Lambda, but haven't really done the cost math there yet. So at the moment, we're looking at doing something kind of like that. Our internal implementation was using Nginx because we have a little bit more of that, but Envoy is definitely on our list to check out. So it's pretty close, but we still need that little connector component between ALB land and S3 land.
Excellent. All right. Thank you very much.
Thank you.